In this video, I'm going to talk through the solutions to the 1A3 homework for interpreting graphs for Algebra 1. So as I look at this one, it says each graph gives a representation for the distance of a person or object over a given period of time. So let's decide which graph matches the sentence. So when I read this first one, my sister got on the elevator on the 3rd floor. So this is where she's starting. She starts high, right? She's on the 3rd floor. She traveled up to the 5th floor, so goes higher. Maybe I'll just highlight these important things. So, start on the 3rd floor, goes to the 5th floor to meet with her friend. When she didn't find her friend on the 5th floor, she realized her friend planned to meet her in the lobby, so then the elevator took her to the ground level. So I start high, go higher, and then go down to the ground. I want to graph the sister's vertical distance versus time. So remember, vertical distance is up and down over time. So when I look at this graph, I'm trying to find a graph that starts kind of high. So this starts on the ground, so that won't work. That starts on the ground, starts on the ground. This one doesn't start on the ground, nor does this one. So then I'm looking at this. We start on the ground, I go higher. Or not start somewhere, but then go higher. So this is starting somewhere, staying there for a little bit. Goes higher. This horizontal line here shows me that I stay there for a little bit. But then she goes down to the ground level. So I would say F is the correct graph for number 1. So going up here, F would be the correct graph. Number 2, I ride my bike to school every day, and I woke up late this morning. In order to get there on time, I rode my bike as fast as I could to school. When I got to school, I realized that it was Saturday and slowly rode my bike home. So when I look at this, first I'm thinking, okay, I ride my bike fast, and then I realized once I got to school, it was Saturday, and I slowly rode my bike home. I want to graph the distance from the school. This is important. Distance from the school. Well, let's think about this. Where am I starting? In this case, I'm starting at the house. So if I start at the house, my distance from the school is far initially. So when I look at this, I need to start far away. So this does not start far away. This does not start far away. This one was already taken, so we're done with that. So when I look at this graph, I start far away. Then this is a really steep line here. So I'm going fast to the school. I have this horizontal line that says my distance from the school is not changing because I'm there. And then I realize, oh shoot, Saturday, I don't need to be there. And then so I'm slowly riding home. And notice this line is less steep than this line. So graph H would be the correct graph here. So go back up here. This would be graph H. Looking down for number 3, I ride my bike to school every day, and I woke up late this morning. In order to get there on time, I rode my bike as fast as I could to school. So the same information. So far, it's no different. When I got to school, I realized it was Saturday and slowly rode my bike home. But now I'm graphing the distance from the house. So this is where it's different. The distance from the house. Well, if I start at the house, my distance from the house initially is 0, meaning the y-intercept, or the starting point, will start on the horizontal axis at 0. So looking down here, both of these, well, all 3, a lot of these start at 0. Okay, so now I need to think about this. I ride my bike fast to school, so I should have a steep line. So this one here has a steep line, whereas this one does not. This is less steep. I stay at school for a little bit, and now the distance from home is now decreasing because I'm getting back home. So A is the correct graph here. So the correct graph for this one is A. And again, it's not G, because this would be riding slowly away from home or towards school, staying at school for a little bit, and riding fast home. All right, and then looking at number 4, I jump roped for 10 minutes, graph my distance from the ground over time. So jumping rope. Well, I got to think about when I'm jumping rope, what's happening to my distance from the ground over time? Well, I'm jumping rope, I'm going up and down, up and down, up and down, up and down. Okay? When I swing the rope swirls. So part of me wants to say D, but I know that this really represents going back in time, or that I would be at 2 different heights at the same time. So it can't be D. So C would be the correct graph. D is an impossible situation, but C shows me jumping up and jumping down, jumping up, jumping down. So C would be the correct graph. Then finally it says Phil runs a 10K race. He starts off running slowly and gradually increases speed. So he starts off slowly, then gradually increases speed. So if I'm gradually increasing speed, I'm going to see more of a curve. And it wants to graph my distance versus time, okay? So the distance traveled, so total distance traveled. Well, at the beginning, I haven't traveled anywhere, so I should start, my y-intercept should be at the origin. So looking here, this one starts at the origin, starts at the origin, starts at the origin, but I'm gradually increasing. This shows me staying at a constant rate. This one shows gradually increasing, so B would not be correct. E is the correct answer for number 5. So that was matching. Now if we flip to the black, we're doing a little higher level thinking skills. Now we have to create a graph. So this says, Billy and Emily go skydiving. Emily jumps off out of the plane and safely floats to the ground. First I want to graph Emily's distance from the ground over time. Well, when I'm doing this, I need to make sure that I label my independent variable down here, my dependent variable here. So distance from the ground is the dependent variable. All right. So now, if Emily is skydiving, she starts high in the plane, and then she'll get closer to the ground. So when I look at this, my thought is she'll start up here, she's going to end in the ground, and it doesn't really talk about how if she goes fast or slow at first. So let's just say, for the sake of this class, you'll worry about it more when you get to physics, that it's about a straight line. Now it wants us to graph Emily's distance from the plane over time. So now when we label this, the independent variable is still time, but now we have distance from the plane. This is different now. She starts at the plane, so the distance from the plane is 0. So she's going to start, y-intercept will be at the origin. And then when she lands on the ground, which is very far from the plane. So at the end, she'll land very far from the plane, and again, for the sake of this class, we'll just draw a straight line. When you get to physics, you may find out that this looks more like a curve than a straight line. All right, moving on to number 7. It says, you and your family go on a road trip. You drive on Beck Road at 45 miles an hour. So that's key. Starting at 45 miles an hour. Before getting on the expressway, we stop to get gas. Then we continue on driving at 73 miles an hour on the expressway. So I'm going 45. I got to stop. And then I have to go faster on the expressway. The first one says graph the distance from our house over time. So time, and then distance from home, or distance from the house. Well, I'm starting at my house. So the y-intercept will be at the origin, at the bottom, at 0, 0. I'm driving at 45 miles an hour at the beginning, and then at the end I'll be driving at 73 miles an hour. So I need to show on this graph that I'm driving slower at the beginning and then at the end. And I know that if I'm graphing distance from the house, then it'll be a less steep line to show that it's 45 miles an hour. So I'm going to be not so steep. There we go. Then I need to stop and get gas. Well, when I stop, I'm not moving, so my distance from my house is not changing. To show that it's not changing, I have a horizontal line. That distance stays the same. And then I continue on to M14, and I'm going to drive 73 miles an hour. It's going to be faster, which means my distance from home is still increasing, but it's increasing at a greater rate. So we're going to have a steeper line. So this is what the graph would look like for distance from home. It's the same situation for part B, but now I want to graph the speed over time. So my dependent variable is speed, and then time is my independent variable. So dependent is speed, independent is time. So let's think about this. At the beginning, well, if you start at your house, maybe you're saying you're not driving at all. You're stopped when you get in the car. So let's say you could say start there. And I pretty quickly get up to 75 miles an hour. So on Beck, I'm driving 75 miles an hour. It says before I get on the expressway, I stop and get gas, which means if I stop, my speed is 0. So I have to have my speed drop back down here. I can't have a vertical line here. It has to be kind of slanted because it takes some amount of time to get to 0. So now I'm stopped for a little bit. This down here represents the same horizontal line here. And then I need to speed back up to 75 miles an hour. So my speed increases, and then I'll drive at a constant rate of 73 miles per hour. So if this was 45 miles an hour, 73 will be higher. So I'll drive up here. I got to make sure that's not a vertical line. It's slanted, so maybe I'll get there fast, but this cannot be a vertical line. And maybe I didn't do a great job. Maybe that looks a little less vertical. And now I'm driving at 73 miles an hour for a while. So this piece in the speed correlates with this piece here, where my speed is increasing at a faster rate. Or sorry, my speed is constant, but the distance from home is increasing at a faster rate. This one, where my speed is 0, means my distance is not changing. And here, where my speed is 45 miles an hour, my distance from home is changing, but at a slower rate than it was at the end. And that's our review.